$3,400 per year, because this is years down here and this is dollars up here, so dollars per year. And then if we want to graph that, our first value, which should go right on our y-axis, should be our first year, so 2004, and this should be 2005, this should be 6, 2008, and there's our 2009 part. And then we can skip some data values, so we can put this little funny squiggly here to say we skip some numbers, and we can start right here at 20,000, maybe 25, 30, 35, 40, 45, and that's all we'll need. Okay, so our first data point is 4 for 2004 for the year, and 41,000, so it'll be right about there. This is going to be estimated. And then 2009, our data is 24, so it'll be up here just almost at the 25. And it says assume the depreciation has been linear, and that's been kind of key in what we're doing here. We're assuming it's a straight line, and because we've done that, assumed it's a straight line, then we can make a graph that goes in this direction. We can also predict values. Since we're assuming it's a straight line, we can say in 2006 it was worth about $35,000. So there's the graph of the depreciation. If we want to finish it out, we would write year and value for our titles on our table. Okay, one for you to try. You can go ahead and pause the video. The number of births in thousands in the United States in 2000 was 4,060. The number of births in thousands in the United States in 1997 was 3,895. Source: National Center for Health Statistics. Assume the increase, so this time we're going the other direction, going up, is linear. Find the slope and interpret it as a rate of change. So again, we'd like to think year first, because we want to say per year at the end, and then births in that order. So we have two ordered pairs. One of them is in the year 2000 and 4,060 births, and the other is in the year 1997 and 3,895 births. And then we can find our M. Remember, it's the difference in the Y's, so 4,060 minus 3,895 and 2,000, difference in the X's, minus 1997. So I know that's 3 years difference, and 4060 minus 3895 is 165, and if I add those two I get 1112, so that's divisible by 3, so I know I can reduce it, divide by 3, and I get 55. And it's positive, so it means it's going up, and that means 55 more births per year. And I forgot one thing, and that's it's in thousands, so it'll be 55,000 more births per year. So when I want to graph that, again, put your first year right there on the y-axis, and that'll be 1997, and that'll be 98, this will be 99, and 2000. And then we need some values going from 3,800 to 4,000. Not a very big change there, but it is in thousands. So then we put a squiggly. We're going to start at, say, 3,500 and 36. This one will be 37, and this one will be 4,000, and this will be 4,100. So at 1997, we had 3,895, so almost 3,900. And in 2000, we had 4,060, so there's 4,000. And 60 is about 2/3 of the way. And you can see that our numbers are going up. And again, we said assume the increase is linear. So we found our slope and then talked about 55,000 more births per year. Last thing we need are some titles. This is the date or the year. And this is the number of births. And we should say in thousands. And this is, of course, for the USA.